Good day, everyone. Sorry for another set of technical difficulties. And I'm going to talk about MySQL replication advanced features in 20 minutes. And I know it doesn't make sense because you cannot cover MySQL all advanced features in 20 minutes. So it will be some that advanced features in hopefully 20 minutes. So first let me ask you, how many of you are using some kind of MySQL replication here? Wonderful, wonderful, right? Yeah, that's we can't do without that. Now, let's see what kind of replication guys are using. Who here uses the classical MySQL replication here? Okay. Now, what about MySQL group replication? What about Galera replication? Oh, wonderful. We have all kind of MySQL replication being presented here. Okay, so let's look before at the MySQL replication first and their history of a MySQL replication, really, how that happened and evolved over time, because I think that is a very significant here, and that is always, I think, historical reason is why MySQL replication is so, what's the word, messy, complicated? Oh, you have a better word, Simon? No? No? I guess, yeah. Is it started fucked and ended it up? Okay, no. I shouldn't say that word here, right? Oh, that's actually Belgium, right? You guys are kind of okay, right? Yes. You know, that's when I'm speaking US, I have to make sure it's, follow all the rules to be politically correct. So that's such a relief. I only have to follow less rules here. But anyway, MySQL replication, it started back in 323, right? And that's the first statement level replication was replicated, which I think first was similar to like a weekend project, right? So it was very similar to cover basic things. And then you can see through versions, almost each version would be adding a lot of new features, right? And for 0, we had a split IO thread and SQL thread. Then in MySQL 5.1, in addition to statement replication, we added the row replication, mixed replication mode. In 5.6, we added per database parallel replication, GTID. In 5.7, now we have other kind of parallel replication, multi-source replication. The group replication was added. I also could add MySQL 8 here, but actually now the most improvements they happen in the group replication, which is designed as a plugin. So most changes are also available in both MySQL 5.7 and MySQL 8, right? So that doesn't mean what nothing great and wonderful happened in MySQL replication since 5.7. It's in a plugin. Now, besides MySQL replication, we had sort of an alternative track which existed now also for what, probably close to a decade, is the Galera-based replication, right? Which is kind of similar to MySQL replication, but that's a lot older code base, and I would call it more mature. And that's available as a patches for MySQL. It's also available from Percona, Percona XRG cluster, and also included in MariaDB. Now, when I speak about replication in MariaDB, I think it's important to note that in MariaDB there are a lot of differences, right? So it's not 100% the same as in MySQL. Right? For example, GTID replication is quite different, right? It has a different features for, parallel replication, right? And we are not going to cover MariaDB features in this presentation, right? Just want to get it out. Okay, so what are we going to call advanced MySQL replication? Right. Well, actually, I'll call advanced everything which is outside of pretty basic MySQL replication, which means, hey, master and a few slaves, and which covers all of those, standard basic features and properties. Okay, let's look into what kind of choices do you really have with MySQL replication and you can make? The first one is you can choose what kind of, how the data is replicated, right? That can be statement replication, then you actually have your queries. You can have row replication, then actual rows are being replicated, right? And then you have a mixed replication, which MySQL, it will make its choice how best to replicate this query, and it will use row replications when a query looks as potentially unsafe to be replicated in a statement mode, right? In reality, both those approaches have some performance benefits and other consideration, and that is something what you may want to make a choice for your application. Now here is another interesting thing, is if you're looking for a row replication, you also can have a choice to figure out how those row changes are going to be logged. If you look at the best approach, right, really from your data, is when you have a full before image of a row and a full after image of a row, right? Why is that wonderful? Because you have a best opportunity to spot the conflicts or data inconsistency. You can also actually go back then, right? When you have both before and after image, then you can replay the logs in reverse order and restore the data in many cases. But the downside, of course, is what your binary logs and the amount of data you have to replicate is huge. So you can have also two additional options. You can say, hey, I would have a minimal row image, in which case only changed columns, right, and a primary key to find them, store in a binary log, or you can use no blob, in which case blobs, which are typically the largest parts of your data, are not logged. Now, if you use a row replication, you can say, well, you know what? My replication got broken, and all I get is this kind of strange error, and I don't know what query caused it, so I don't know what application corresponds to, and so on and so forth. Then you can also log the query for informational purposes with this bin log row query log events, which is quite helpful feature for troubleshooting. Okay. Now, what can you replicate? Now, in your case, I would say the most simple practical way to replicate is a full database, right? When you have full database replicated, it is wonderful from troubleshooting standpoint, from operational standpoint, like you can take a backup from one of the nodes and restore that to any nodes. But at the same time, MySQL is much more flexible with that. You can both replicate only part of the data, as well you can choose to add additional data to the slaves if you choose to. What kind of filtering do we have? We have two ways to deal with that, actually. There are options either on the master itself. You can select what options you can, what data you're going to write in the binary log, right? And you can also filter on the slave, and you can choose what data you want to filter. Now, there is some relatively complicated interaction of how those options work exactly, depending on whether you use statement replication or row replication, right? So at least mind what the replication filter in MySQL is complicated, and I would think where you actually really need to use it. Again, full database replication typically is the most practical. Especially be mindful about filtering on the master, because remember, binary logs are not only used for replications, they're also used for your point-in-time recovery from backups, right? So if you don't try to back data in your binary logs, you also use opportunity to do point-in-time recovery using the binary log backups. Okay, the next question is how a position is identified in the MySQL binary log, right? There are two choices. One is your binary log position, when you pretty much identify that by the file and by position. The challenge with this simplicity, right, also comes a challenge that position is going to be different on your master. It's one position, and on the different slaves, it will correspond to potentially very different positions, so failover is complicated and so on and so forth. You can also identify that by GTID, right, which kind of handles all of that positioning much more fancy, but it's also much more complicated. So what is GTID in MySQL? Again, in MariaDB, GTID is different. That's one of the biggest differences in the replication. GTID looks this way, right? You would have the source ID and some transaction ID information. And this value of a GTID for transaction is always preserved on the slave, right? Even if you have a multi-tiered, very complicated MySQL hierarchy, the GTID of a transaction will be preserved as these transactions goes through a slave. Now, benefits and drawbacks, of course, is what you have automatic position discovery. You can say, hey, you know what, start replication, right? Or on the slave after you restore backup, for example, it will be able to figure out GTID. You can simplify slave promotion. You can also spot and discover if there are some transactions which have been missing in some cases. But it's also pain in the ass for manual troubleshooting, right? With your position-based stuff, you also have a simple, hey, you know what, there are a few transactions which you can, skip. You have some rows missing. You can always, just manually apply the updates. With GTID, it becomes substantially more complicated. Replication topologies. MySQL is now super powerful in terms of what kind of replication topologies you can use, right? You can have a single-tier master slave, which I already displayed. You can have a replication which is set up bidirectional. You can have any kind of tree. You can have a ring, also called circle replication. You can, but you shouldn't. MySQL replication is a very, very powerful food gun. It allows you to do many, many things which you should not do, right? Remember that. And you can also, especially with multi-source replication, you can pretty much set up very fancy directed graphs, right? You can have a fan-in and fan-out replication. So, oh my gosh, you can, have become very creative for your Doom. Okay, so what kind of options do we have for dealing with those more complicated advanced topologies? Log slave updates, that is a most important one, which is also on by default in MySQL 8, right? Which allows you actually to have slaves of other slaves. Parallel replication, that is a very important feature to keep in mind. The replication is often limiting performance factor if you don't enable parallel replication. It's available since 5.6, but only in 5.7 you have this logical clock kind of parallel replication, which really allows you a truly parallel replication, even if you have a writes going in the single database. Okay, standard MySQL replication is asynchronous, right? What that means is when you do the writes, data persistent on the market, and then it's eventually transferred to the slave, and even more eventually is applied to that slave, right? And eventually, hopefully means a few milliseconds, but hey, I have seen the MySQL replication lag of being more than a month in some cases. Anybody else? Yes, so eventually may mean many things, right? And that replication lag is unbound in MySQL replication. There is no, unless you have some external monitoring, MySQL will not complain about having any MySQL replication lag out there, right? And what you also have to know in this case is with asynchronous replication, if a master is crashed and lost, some data loss may occur because even that network transfer happens in the background. Now, there is an option for MySQL replication called semi-synchronous replication, which requires a plugin. And then if you use that replication doesn't become synchronous, right? But at least the data would be transferred to the slave synchronously. So if master crashes, the data loss can be prevented. Right. There are a bunch of semi-sync replication options which you may want to review, but in the interest of time and keeping Fred happy, we're not going to go in them in more details. We'll talk in another thing you need to know about MySQL replication. MySQL replication allows you to set active master replication, right, in this case. But again, because it doesn't have any kind of conflict detection and resolution, you should not use active master, right? You also should use active passive master, right? If you use MySQL group replication or use Galera-based solution, it has had it much better in terms of preventing or avoiding conflict. Now there are some people who still absolutely want to use active, because they thought they have designed the application to avoid content, right? Or they want to make sure they can write to it, two sides at the same time for performance reason, and they don't care about their data. These are probably the same kind of people who still run MySum tables. Right, but anyway, right now, if you want to feel on the risky side, there are some features you should be aware. To reduce amount of conflicts, right, reduce kind of errors, you can configure those different sides with different after increment offset and after increment, and also there is this fancy slave execution mode, which is important, which allows MySQL replication to ignore a lot of data, just overwrite conflicting data with no warnings, right? So if you don't really care about data consistency, then here is a recipe for you. Okay. So in terms of replication position information, that is another thing that MySQL gives you a lot of choices, right? You can figure out where the data will be stored in terms of position information, repository where it's file or table. If you store that in file, then it typically gets very hard to synchronize, right? In case of power loss, right? So we can see in general trend moving that information to the table with MySQL 8. Though through the years that also would come with some performance issues. So the MySQL master slave replication is the most commonly used variant, right? As we saw, and we had a pool here with raise of hands, right? So you don't have to just believe me; you can believe yourself. MySQL group replication, I think, is another up and coming option, which, in my opinion, is technologically much more superior, right? Conceptually to the standard replication, especially in our age of cloud, when you want to spend less and less time to manually, maintain the system. So what is a group replication overview? As I mentioned, that came after Galera replication. Well, that's not official, that's my belief, but that was inspired by Galera ideas and its success in the market. The great thing about that, the group replication, I think, is what it is built on the top of a MySQL standard replication. It uses still binlog, GTIDs, right? It doesn't live here kind of on the side. It's available as a plugin for MySQL 5.7 and above, and that is considered GA at this point, and that is very actively developed. We can see even in the new releases of MySQL 8, right? Every release gets a lot of super cool improvements in the group replication. In terms of difference from MySQL replication, there is no more this kind of master-slave relationship. You can have a group of nodes, right? And all the groups kind of know about each other, right? And manage as a set, while there is in default configuration, one of the nodes which is primary is taking writes, and other can be used for reads and for failover. There are a lot of consistency checks in this case involved, right? So, for example, if a node lost network connection, right? It will be removed from a cluster. Cluster itself promotes other nodes to primary, right? So you don't have to have the external tools to do that, and so on and so forth. And there is a lot of work for simplifying failover and so on and so forth. As I mentioned, for writes, group replication configures by default a single primary. You can also configure that in a multi-primary setup, but it's not recommended because there are some features which don't quite work with it yet. Now, what I can see as the limitations in the MySQL group replication, then there is no automatic node provisioning, hopefully yet, right? So you still have to make sure the data is somehow magically restored to be the same on all nodes before you kick it off. And there is still, you have a manual node recovery in a network failure, right? So if you had some network connection which was kind of disconnected for a few hours, right? Few hours, the node would not rejoin and resynchronize that. But I am very happy to say what in the time I did this replication last time, there was also no way to prevent a stale reads from the nodes. Now it was fixed, right, in the recent release. So I'm glad that the list of my complaints is shrinking. Also, with MySQL group replication, we have MySQL in a DB cluster, right? That is kind of more high-level package, which also includes MySQL shell and the MySQL router for traffic management. Finally, if you are not using MySQL cluster, right, and still, well, you know what? If I just still use classical MySQL replication, how to make it kind of more robust and less painful, right? There are a few tools come from community which should be aware about. If you're looking to automate your failover, the leading solution right now, I think, is Orchestrator. Should know that. If you're looking for read-write splitting, traffic management with lots of features, you know, again, coming from community, open source, Proxy SQL. And if you are looking to get, let's say, some sharding for MySQL, right, the VTest at this point is a leading solution. And that's all I have. Did I keep you happy, Fred? Of course. Wonderful.
You can answer one or two questions. Just repeat them.
Yes. Okay. Questions? Any questions? Okay, you know. Oh, yeah, go ahead.
In which situation you think it's still right to use Galera replication and we should not go to the group replication on it? Could you repeat the question?
Yeah, the question is in which case you should use Galera replication, should not go to the group replication. Well, I think what you may want to evaluate, right, those solutions, what works for you, what doesn't. There are some other differences as well. In my opinion, generally the Galera still has an edge in terms of its robustness, right? Obviously, it was around for much more years, right? But I think the group replication has been catching up in this regard. Yeah. How many nodes you can have with group replication versus with Galera? Well, honestly, I don't know quite if there is a specific limit, right? I mean, typically it goes into the practical limit.
No, in group replication it's 9.
In group replication, that's 9, right? But I think you know, it's unlikely you need much more than that, right? Well, thank you.